Hi, today I'll be trying something new, and no, that's not taming a tiger. Tigers are always going to be wild regardless of what humans do, and I think that's why I love them so much, beside the fact that they are so damn beautiful. Anyway, I'll be solving not one, but 3 coding challenges, and this thing is going to have chapters, so you can check them out individually, stuff like that. Okay, first is going to be get this background using a single div, no pseudos, no SVG, no images in general, save for at most 3 CSS gradients, and at most 5-6 declarations, including sizing, prettifying, layout, custom properties, that kind of stuff. Okay, we already have our div. We're going to maximize the CSS panel because we won't be writing anything else. We are going to have a few styles that you may have already seen in my previous videos. So on the HTML and body, we're going to set display grid, and then we're going to make the HTML full viewport height. So that means height 100%. Now, the cool thing about grids is that the grid items, more exactly their margin boxes, stretch by default all across the grid cell that contains them. So this means that our div is going to stretch all across the one grid cell of the body grid, and the body, its margin box, is going to stretch all across the one grid cell of the HTML grid. Now, the HTML grid stretches all across the HTML element, which stretches all across the viewport. So basically, our div is going to cover all available space minus the body margin, which we don't need to bother with anymore setting these styles. So let me just show you that. Jump straight into the background. We're going to have a linear gradient, and we're going to go along the main diagonal, so this way, and I kind of need to check my scars for the direction. So that's going to be a right, bottom. I know the difference between top and bottom. Left and right are a bit more difficult. So we're going to start from white up to 20%, and then we're going to have another 20% stripe, which is going to be a very light gray. So up to 40%, that's 20 more percent. And now we're going to take this and copy paste it, and then I'm just going to modify in what I've pasted here. So we're going to have ever darker stripes. So D, C, B. Hooray, I got the alphabet right, backwards even. 20 more percent, we're going to get to 60%, and 20 more percent, 80%. And that's it. We have our stripes gradient along the main diagonal, and we're going to copy paste all of this, right? And we're going to modify the direction, so we go along the other diagonal. Okay. But this is not quite what we want. We don't want the top gradient layer to cover the bottom one. We want to actually mix them in some way. So we're going to do that using blending, background blend mode, multiply. And let me just show you what this does. And by the way, all the tabs that you see right here, all these links, they are going to be in the description, so you can find them there. Now, this is an article from an article that I wrote, and we have a top layer, a bottom layer, and a resulting layer. And each of these layers can be considered as being a grid of pixels. So we combined the channel values of one pixel from the top layer with the channel values of another pixel from the bottom layer in this black box right there, and we get the channel values for the pixel in the corresponding pixel in the resulting layer. Now, corresponding pixels means they have the same row index, the same column index, right, in these grids of pixels, which have the same dimensions. Okay, so for multiply, things are a lot easier than for other blend modes, because for multiply, we take the channel value for red of the pixel in the top layer and multiply it with the red channel value of the corresponding pixel in the bottom layer, and we get the red channel value of the corresponding pixel in the resulting layer. So the same for the green and blue channels. Now, in our case, where we only have grays, we're lucky. All 3 channel values are exactly the same for all grays, going from black to white, if you consider black and white also being grays, whatever. Anyway, we have this decimal representation from 0 to 255, and this percentage representation from 0 to 100%. And this is the one that we'll be using for the computations. So 0% is going to be 0, 100% is going to be 1, 50% is going to be 0.5, 75% is going to be 0.75. So like that. Okay, now this completely white is going to have all 3 channels 1. This very light gray is going to have all three channel values 0.93. This other slightly darker gray is going to have all three channel values 0.866, we can say 0.87. Okay, now we are going to take this stripe which goes from that corner to this 20% line and its intersection with this stripe right here which goes from the 20% line to the 40% line, and that intersection is going to be right there, and the RGB channel values there are going to be 1 times 0.93, which is 0.93. And one thing to notice about multiply is that the resulting value is always going to be at most as big as the smallest of the two factors. In our case, the two factors are 1 and 0.93, and the result is going to be 0.93. But we can also take this stripe right here from 20% to 40%, so this stripe right here, right, and multiply it with the corresponding stripe in the bottom gradient, which is going to be this one right here from 20% to 40%. Their intersection is in this rhombic area, right, and we're going to have 0.93 times 0.93, which is going to be something like 0.86, right? So that is going to be the resulting channel value. 0.86 is smaller than 0.93, okay? And we could also take this stripe from 20 to 40%, so from 20 to 40%, and the intersection with this other stripe from 40 to 60%, right? So their intersection is that rhombic area. So we're going to have 0.93 times 0.87, which is going to give us 0.80, 0.81, something like that, right? And you can see how it's darker than 0.93 and darker than 0.86, right? So this is how multiply works in the back and how we get these rhombic intersections. Okay, now we're going to add one more gradient layer to multiply it with these two bottom ones. Now, when we have multiple layers, right, we blend the bottom two ones, and then the third layer from the bottom, we blend it with the result of blending the bottom two ones, okay, and so on. This is how we do it when we need to blend multiple layers. Okay, so one more linear gradient. This one is going to go in the positive direction of the x-axis, so towards 3 o'clock, and it's going to go from white to black, though I think this is going to end up being too dark, black there, and we're going to restrict its horizontal dimension to 2.5%, and yeah, black is too dark there. Let's because we can't distinguish those rhombic patterns underneath, even though we're multiplying this layer with the result of multiplying these two other layers. This one is just too dark, so dark that it's too dominant, so we're going to make it lighter. Okay, so now the rhombic patterns are a bit more obvious. Okay, but we don't want that blurriness. We want sharp lines, and we're going to get that by applying a contrast filter. So contrast, let's say 27. And this is going to give us the result we were after. We can also tweak this, but I think I probably shouldn't waste time doing this, right? Just leave it at this. Yeah, this is one of the reasons why I shouldn't waste time doing this, because there is a risk of making mistakes. But before we move to the next challenge, I want to show you how contrast works. So again, this is from a talk, the slideshow from a talk that I gave, and this is basically the most relevant part in our scenario. Now, contrast value is smaller than 1, which is not our case. 27 is bigger than 1, but just so you get an idea of how it works: smaller than 1, equal to 1, bigger than 1. Now, contrast values that are smaller than 1 push the RGB channel values towards the middle of the 0 to 155 interval. So, or the middle of the 0%, 100% interval, so towards 50%, however you want to consider it, it doesn't matter. A value of 0 is going to push them all the way to the middle, to the 50% gray. Now, let's see a few practical examples, right? So now the contrast is at 1 or 100%, which leaves everything unchanged. A contrast value of 1 or 100% doesn't make any changes to the initial element, right? But if we decrease this contrast value below 1, below 100%, so now we're at 0.65 or 65%, and we go lower and lower, and we get all the way to 0, you can see how we get the same gray for all of these. This one also has semi-transparency, so that's the only difference. Now, contrast values that are bigger than 1 are going to do the opposite. They're not going to push the channel values towards the middle. They're going to push them towards the nearest end. So which is nearer, 0 or 255? Large enough values are going to push them all the way to either 0 or 255, which means that large enough values are only going to give us pixels that have one of these possible RGB value combinations. So there are 8 possible RGB value combinations where the channels are all either 0 or 255. Okay, now we have this background which has an RGB 255 already maxed out on the red channel. 155 is closer to 255, so it's going to go up. 84 is closer to 0, so it's going to go down. So a large enough contrast value is going to push this to 255, 255, 0, which is basically yellow. Let's see it. You can see how it gets more and more yellow, and now it's practically yellow, right? Now let's see for a gradient. Now here at the top, right, 255, 0 already at the ends. 153 is closer to 255, so we're going to have 255, 0, 255. That's basically that magenta, right? And here all 3 values closer to 0, they're going to go down to 0. Again, all 3 closer to 0, going to go down to 0. Here we have 255. 127 is very close to the middle, but it's still closer to 0. So it's going to go down to 0. 81 also going to go down to 0, and this is the same color as before, right? So you can see how we go from a gradient, smooth gradient transition, to those sharp line transitions. Okay, now one final one. And that looks like very much like that midway gray, that 50% gray. Now 50%, which way does that go? Well, let's see. Starting to get interesting. And by the way, those black dots there, those are just some artifacts. That's a bug. Those black dots are a bug. Ignore them. Anyway, so the reason for this is that we don't have the exact same gray. So here we have 127 on all 3 channels, right? 127 is closer to 0 than it is to 255. So from a certain contrast value, we're going to have black there. Now here we have 128 on all 3 channels. 128 is closer to 255. So from a certain point on, from a certain contrast value, we're going to get white there. And this is what we're applying in our particular demo, where before contrast, we only have grays, right? So all those grays there that are closer to white, they are going to become white with a large enough contrast value. And all those grays that are closer to black, they're going to become black past a certain contrast value. So let me just show you another one. This one right here. So you can see again we have this sort of blurriness, this gradient thing from black to white, right? And if we increase the contrast value, right, you can see how we're going more and more towards just black and white. So all the grays that were below 50%, so closer to 0%, they went to black. They went to 0, to black. All the grays that were above 50%, closer to 100%, they went to 100%, to white. So that's the thing, that's the trick right here. Now, next challenge. Get this thing right here. With a single div, no pseudos, no JS, no SVG, no images in general, save for 2 CSS gradients, gold to purple and crimson to aqua, at most 7 CSS decorations, sorry, and tweet size under 225 bytes. And the roundings should be 4 M's for the inner one, 1 M for the outer one, and 1 M for that spacing there. Okay? So now let's see it. We have our div. We are going to start with dimensions. So, right, we're going to use aspect ratio, for which we don't even have autocomplete, unfortunately. And we're going to have background, and it's going to be a linear gradient, crimson to aqua, right? And now we're going to go to the box model. And this is something that I went into in this article, which again is going to be linked in the description, as well as all the other resources. So everything is going to be linked in the description below. Okay, so we have the content box, inside the padding box, inside the border box. So that red area is the padding area, that orange area is the border area. Now, if the border width is 0, then the padding box coincides with the border box, right? And if the padding is 0, then the padding box coincides with the content box. If both the border width and the padding are 0, then all 3 boxes coincide. Okay? Now, another thing we can do here is have different backgrounds on different boxes. So here we have one background restricted to the content box, one background restricted to the padding box, and another one restricted to the border box. Now, this is what the background clip in the title does. It restricts the background to a certain box. So, for example, the content box, the padding box, or the border box. So this is how we can get multiple backgrounds on multiple boxes without using pseudos or children elements. So we are going to add here padding and a linear gradient, gold to purple, and this is going to be restricted to the content box. Me and keyboards, we just don't get along. Okay, now we have those gradients. Now, next step is set a border radius. Now, we want an outer radius of 1 m, right? And that's the radius of the outer box. But one more thing to be noted here, when we have a border width of b, a padding of p, and a border radius of r, let's just see how that rounding works. So that r is the rounding for the border box. The rounding for the padding box is the border radius r minus the border width. The rounding for the content box is the rounding of the padding box minus the padding. So in our case, the rounding of the content box is going to be the rounding of the padding box, which is the same as that of the border box in our case. Border width is 0, right? So that's going to be 1m minus the padding 1m, which is going to give us 0. But we want the inner rounding to be 4. So that means we should have here a border radius of 5m, but that makes the outer rounding bigger. So how do we fix things? Well, we're going to increase the padding, so to, let's say, I don't know, something like 3m, right? And then we are going to use a clip path. And we're going to use the inset function for clip path. So the inset function for clip path works like this. So we have this d value, which is basically the inset, the distance from the edges of the border box, which in our case coincides with the padding box. Okay, so that's going to be the distance. And the rounding of this clipping rectangle is going to be independent of the padding and is going to be independent of the border radius. We just specify it there. Okay, so Let's see that. Clip path. Now we want a distance of 1m, so we're going to have inset 2m, right? Because 3m minus 1m is going to give us 2m. And then we're going to have round, and the rounding is going to be 1m. The outer rounding we want it to be. So we could also make it 2m's, right? Or we could make it 0.5m's, right? And it's independent of anything else. Okay, now you may be thinking, last step, box shadow, something there, and nothing shows up. Well, this is something, again, I went into in another article. So we have our element, we set a shadow on it, right? And then we apply clip path. And this cuts out everything outside the shape, including the shadow. So what do? We use a drop shadow on the parent. So we have our clipped shape, and then we set filter drop shadow on the parent. So let's do that. The parent of our div is the body. Filter, drop shadow, and we're actually going to take what we have there, right, and put it in there, and this does it. Okay, we're done with the second challenge. And now let's move on to the final challenge, which is an SVG one. Get this SVG arrow, right, with transparency in the middle, using a path that only contains 2 straight lines, and the whole SVG should fit in a tweet, so it should be small. Okay, let's see. We already have the background, right? And we have this box shadow to highlight the boundaries of our SVG. And we're going to start by setting a viewBox on our SVG. Now, let's go here to understand how the viewBox works. So the viewBox has 4 values. And these 4 values, what do they represent? The first one is the x-coordinate of the top left point. The second one is the y-coordinate of the same point. The third one is the viewBox width. And the fourth one is the viewBox height. Now, in this case, where the coordinates of the top left point are minus half the dimensions, right? This means that the 0, 0 point of our viewBox is dead in the middle. So it's dead in the middle horizontally, dead in the middle vertically. This is the x-axis, this is the y-axis, right? And they split our viewBox into halves. Okay, now in our case, we're going to want our 0, 0 point to be in the middle vertically. So this x-axis is going to be dead in the middle. It's going to split our viewBox into a top box that's equal in size to the bottom box. But this y-axis is not going to be quite in the middle. It's going to be a tiny bit offset, because we're going to want it to pass through that point, which is the tip of the middle arrow line. Okay, so that's going to be our 0, 0 point. So viewBox, right, is going to have x, y, 4 and 4 for the dimensions. So y is going to be minus 2, and not quite in the middle, we're going to have minus 1.5, sorry. Okay, so now we're going to want to draw a line, right, from that point right there, the start of our arrow, to that middle point, the tip of our arrow. So let's say that that point is going to be, so obviously its x-coordinate is going to be in the positive direction, right? Its y-coordinate is going to be with minus, and let's say it's going to be 1 minus 1, and it's going to go to 0, 0 next. Okay, so path, of course we're going to need to set a stroke to white, and the path data is going to be we're going to go from 1 minus 1 to 0 0. So that means to get from 1 to 0 we're going to need to subtract 1. To get from minus 1 to 0 we're going to need to add 1. Let's see that line. Stroke. I can't type. Okay, so now we have our line right there. And then we're going to have a second one to the symmetrical point. So the symmetrical point with respect to the x-axis, which splits everything into two symmetrical halves, right? That point is going to be 1, 1. So to go from 0 to 1, we add 1. Let's see. Okay, so that's our arrow. We're going to need to get rid of that fill in the middle, right? Because we have that black fill. So fill, none. Actually, let's add some circle. Let's actually put them all inside a group. And the first one is going to be, so 1, and y is going to be minus 1, and the radius is going to be 0.1, right? So like this. Then we're going to have 2 more such circles. This one is going to be at 1, and this one is going to be at 0 0, so we don't need to set those two. Like that. So basically our fill, if we didn't set it to none, is within that triangle, right? Right there. Now if the stroke was something like this, right, you can see the triangle between those points, and I think that is a bit too big of a radius. Something like that, perhaps it's more appropriate, like that. Let's actually make it like this, because it contrasts more with, I think. I don't know, what contrasts best? Green? No. Blue? That's kind of stupid. I can just make it a bit bigger, like this. Okay, so we need to get rid of that fill. That's why we had fill none there. And next we're going to want to add roundings to those ends. So basically we're going to add roundings that have a radius of half the stroke width. So the distance from there to the edge of the stroke. So the radius of the rounding is going to be half the stroke width. And for that we're going to use stroke-linecap. And the default is just but, which you can see the end point there, the end points of that line, right? And there's nothing beyond them. But for stroke-linecap round, we get those half discs of radius half the stroke width. Okay, so we are going to have stroke-linecap round. So now you can see that nice rounding there. Okay, let's get rid of that alpha. And we're going to need to take out something from the middle, make it transparent. So it would be sort of like having another path with a thinner stroke. So stroke with 0.5, and also just so that it contrasts, make it black. Okay, so we need to take out that part, and that's pretty much how we're going to do it with these two paths inside the mask, because masks in SVG are luminance masks. So what does a luminance mask mean? The alpha is going to be the luminance. The luminance for black, 0. The luminance for white, 1. So here, alpha 0, complete transparency. Alpha 1, complete opacity, right? So we're going to add here an ID so that we can use that same path as it is, and also a thinner black copy, like here, except with use. Like this, right? Let's get rid of that. And let's add the mask. Okay, so that worked, but there's a glitch. It worked properly because of a glitch. Okay, so you see, that's the problem. The mask by default stretches 120% of the box width, of the element's box width, and 120% of the element's box height. Now in this case, the box width is smaller than the box height, so it's not going to be enough. This is why we get the horizontal clipping. So what is that box exactly? Let me just show you. So we're going to have the exact same path. Right here, stroke none. Okay, I messed up something. Oh yeah, that's what I messed up. Okay, stroke none, fill red. Oh, I get that default fill. Okay, so that is the box, right? And we get 120% of that, which gets cut off somewhere there, 120% of the width. So we need to make the mask dimensions, the mask width and the mask height, we need to make the mask extend more than 10% in each direction. So these are going to be the top left corner offsets, X and Y, and width and width and height are going to be the mask dimensions. So X is going to be -2, Y is going to be -2, and so like this. Okay, so we have our result, and it looks nice, and it's super compact, and it's hand-coded, it's easy to understand, there are no complicated cubic Bezier lines, and it's easy to edit manually. So we can make it smaller, shorter, longer. So we can, for example, go to 1.5, and then again, actually we should use 1.5 everywhere there, right? 0.5, like that. Right? We can easily modify it and all that stuff. Yeah, that's it. I'm going to stop here, stop talking. This is it for today. I hope you enjoyed this video, and if you like the work that I'm putting out for over a decade now and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon, or if monthly support is not your style, there's the option of a one-time donation, or you can make the stray cat happy with a gift of her wish list. The links for everything, as well as the links for the resources, are going to be in the description, and I'll see you next time.